Hello, welcome. In my last class, I was trying to explain to you the way to solve the problem using inertial force or pseudo force. Now, without pseudo force, we have seen how to solve the problem. You have to use the constraints. And if you use this, you may not require the usage of constraints everywhere. Okay? One important thing that you should remember, when should you use pseudo force? Choice is yours, number one. Number two, whenever you want to apply Newton's second law from a non-inertial frame or accelerated frame, one technique is to adopt this pseudo force concept or imaginary force concept and get the solution. Once you use pseudo force concept, you will never get, remember, you will never get the absolute acceleration directly. You will get only relative acceleration. If I'm using pulley as the system, you will get all values with respect to the pulley. Likewise, you should understand. And what is this pseudo force? Only one pseudo force I am talking about here. Other pseudo forces I will not discuss at this stage because it needs a separate discussion. I will definitely do that in detail, but afterwards, not now. Not now, okay? Now, how to use this pseudo force? If this whole system is accelerating with A, if I am inside and I want to observe it, I want to write the equations, I want to solve it, then what do? Apply a pseudo force on this in addition to the existing real forces. That's why I have written sigma f real plus sigma f imaginary is equal to mass times the relative acceleration. Okay? Now, what is this pseudo force? I told you. You have to take m times minus as. This is your pseudo force. Now I'll give you an interesting thing. Sigma f bar is equal to ma a with respect to, say, ground, fixed point. Now if I take a real, suppose if I take real plus imaginary, then I will get acceleration of, I'll say body B. Body with respect to system. Whichever system you are taking it to be accelerating, that is what I am trying to work out. Okay? Now there is a small adjustment. I am doing it. Bear with me. All right. Sigma FR, sigma Fi is equal to mjbs. What is sigma Fi? The total is nothing but minus mjs. What is this? MAB minus MAS. Got the point? Now this and this cancel. So what are you getting? This is nothing but your original relation. Now I want you to understand, using pseudo force is not going to do any great thing other than allowing you to solve it rather easily. And I have proved that Newton's second law is untouched. So be careful about this. Now, with this little background, I will explain how you apply pseudo force to this problem that we have just discussed a little while ago. I draw that body as before. Right. As far as the first one is concerned, there is no change. Now I'll take A1 so that AP is downwards. And I know that this is, for this rope there is no fixed pulley. So I've got minus A1 plus AP is equal to 0. Therefore A1 is equal to AP. Okay, fine. How do you write the equation if this is 1? T1 minus G is equal to 1 into A1, this one. Now here, AP, we have seen this is T2. This equation will not change. This is also the same thing. But what is important here is, if I am taking with respect to this, what is the acceleration of this frame? Downwards. So if I am applying on this body inertial force concept, I must take it to be acting upwards. I'll draw the inertial force concept here. M2, that is to AP. Pseudo force. What is the real force? Sorry, 2G, and this is T2. So, as I said, you will get relative acceleration. With respect to this, I know lighter body will move up, heavier body will move down. So, what do I do? A to P upward. So, how do I write the equation? T2 plus 2AP minus 2G is equal to 2A to P. Hope you are able to understand the way I am writing the equation here. In a similar way, 3 kg mass, this will be pseudo force 3AP. Why this pulley is accelerating down, minus MA therefore upwards, and this is T2, this is 3G. And I told you, whenever you use pseudo force, you will get only relative acceleration. How do you write this equation? Coming down, therefore, 3G minus 3AP minus T2 is equal to 3A, 3P. Okay? Yeah. And AP is nothing but A1. So I can replace this with 1. Okay, we will try to eliminate tension from this. One, two, three, 4 equations. T1, T2, A1, A to P, A to P. Now, A to P is, we will call it as AR. So A3P is minus AR. But here what did I do? I took already up or down. Therefore, 2AR, 3AR. When you were using constraint relations, these accelerations were different. But when I am using this pseudo force, with respect to this is a constant rope length having same constant length. So heavier body will go down with certain value, it will go up with the same value. That is the crucial point here. Same thing cannot be taken in the case of absolute frame when you use constraints. Therefore, now the number of variables is reduced. So, what do we do here? A1, we will okay. the T2. Instead of T2, what do we write for A1? A1 is equal to 2T2 minus G, or 2T2 is equal to A1 plus G, or divided by 2. I'll substitute it here. A1 plus this plus 2A1 minus 2G is 2AR. What about this? 3G minus 3A1 minus T2 minus A1 by 2 minus A by 2. Now, you can see there are two equations in A1 and A2. Now simplify it the way you want. Multiply throughout with 2, 4A1 plus A. You get 5A1 minus 3G is equal to 4AR. In a similar way here also, if you do it becomes 6, it becomes 6, it becomes 6. Minus 6 minus, so minus 7A1 plus 6G minus 5G is equal to 6AR. Okay? Now multiply with 7, multiply with 5 and add. This gets cancelled. So this is minus 21. And what is this? Minus 21 plus 25. What is this? 28 plus 30. 58 AR. So what are you getting? Now you compare this with this. You can directly get that relative acceleration from this. And if you get relative acceleration, you can get absolute also from the same analogy that no, you work out here, you can work out here when you will get the same answer. Answers cannot be different, technique is different, that's it. If sometimes they ask you relative acceleration, use pseudo-force technique. Sometimes they ask absolute acceleration, you are more comfortable dealing with constraints, do that. Whichever way you want, you can do that. I hope this problem is clear. I have dealt with in great detail. Therefore, you should not have any questions on this. Even then, if you do have, as I said, put it in your comment form so that I can address them. All right? Now, continuing the constraint tirade, what I'll do, another case I have given here. Now you have, what is the constraint relation? Now, as I said, if you take both down, single row, you could see only one constraint relation you get. Use the same technique. Plus A1, 0. This. Plus A2, 0. This. 0 plus A2. What are you getting? A1 plus 2A2 is equal to 0. That's how you get it. How do you write the equation? I'll just write and leave it here. As I said, you can do it on your own. Same tension now. This is going down, therefore M1G minus T is M1A1. Here T, and 2G minus 2T is M2A2. So 3 equations, 3 variables. Now you can solve it, okay? Right. Now, if I extend this to any number of. Don't look at the diagram and get perplexed. You can draw as many as you wish. These are variable pulleys, these are fixed pulleys. As I said, you take everyone down. So how do you write now? Now it should be little quick. Plus A1, plus A2, plus A2, plus A3, plus A3, because these are all zeros. Oh, A1 plus 2A2 plus 2A3 is equal to 0. Let them give any number. This is how you have to write the constraint relation. These are all fairly simple cases. Wherever you come across, this is how you have to do it. Now, this is very, very important. Okay? Now, you got like this. Now, let me go to another case. Now, look. Two pulleys, body number 1, body number 2, as before, A2. It's up to you. As I said, it makes no difference. You can do. And this is AP down. So, two ropes, two equation. First row fairly simple. What? Plus A2 plus AP is equal to 0. First rope. Second rope. Plus A2. What is happening to this? Decreasing. Plus A2 minus AP plus A1 minus AP is equal to 0. Second row. What are you getting? Here AP is equal to minus A2. So you become A2, A2, A2. What are you getting? A very, very interesting result. A1 plus 3A2 is equal to 0. How do you write the equation here? Look at this. This is, I'll take it as T2, T1, T1. One simple thing about this is obviously T1 is equal to 2T2. Now this M1G minus T2 is equal to M1A1. And here, see, T2, T1, M2G. M2G minus T1 minus T2 is equal to